Hi everybody, this is Mrs. Lehman from Math with Mrs. Lehman. I'm here with my third period class again. Hi. So I'm glad you joined us today because today we're going to hop in a van, not a creepy van, but we are going to hop in a multi-passenger van and take a little road trip to a what van? A friend. That sounds even creepier. Okay, we are going to go to Five Guys Burgers and Fries, and we are going to pretty much do some statistical analysis for Five Guys, because what happened, this is made up by the way, what happened is they were finding that there was a big discrepancy in the number of fries that people were getting when they ordered a size large. Some people were getting, complaining that they got barely any fries, and then other people were walking out with a grocery bag absolutely full of greasy fries to the point where the bottoms of the bag was like falling out. So they wanted us to go in there and study the number of fries that people were getting so that they could become more consistent with their branding and, what people would expect when they order a large fry. So pretty much, we're going to call it Restaurant A, wink wink, Five Guys, and they advertise that a typical number of french fries in a large bag is 82. The graph shows the number of french fries selected in selected samples of large bags from Restaurant A. So what we're going to focus on today is the median. And so what the median is, let's define that. The median is the middle. All right, do you guys remember Hey Diddle Diddle? Yeah, you guys saying that, right? Some recited it in a poetic way. You want to do that again?
Yeah. You guys remember it. Hello, diddle diddle. Thy median's thy middle. You add and divide for thy mean. Thy mean is thy median. Oh. The mode is thy most. That you see the most in the mean is the difference.
We're gonna try that again. It goes, hey diddle diddle, the median's the middle. You add and divide for the mean. The mode is the one that you see the most, and the range is the distance between. Yeah. All right. Yeah. So nice try. It's been a while, and you were being extra creative with that, so we'll forgive you. The median is the middle. So what does that mean? It's the middle. So that means that's the point where 50% of your data is above the median or greater than the median. And it is the point where 50% is below that amount. All right. Now the real benefit of using the median is high numbers and low numbers are not going to impact the median the same way that it would impact the mean. When we have a mean, if you throw in a really gigantic number, it's going to bring that average way up, right? Where with the median, you could throw in some big numbers, some low numbers, and it's not going to pull the median, in either of those directions. Question?
I want to do the Hey Diddle Diddle thing.
Oh, okay, Jaden needs to do this.
Hey diddle diddle, the median's the middle, you add and divide for the mean. The mode is the one that you see the most, and the range is the difference between.
Oh, I'm sorry, that wasn't Jaden, that was a robot that came in. Okay, so anyway, we're going to, first of all, we're already at Five Guys, Restaurant A, and we've all gotten a bag of fries, okay? So we are going to count the fries before you eat them. We're going to put them on a dot plot. Oh, fast forward. Oh, look, they're already on the dot plot. Now we need to make a list of the number of fries everyone got, starting with the lowest amount. So when you're doing the median, you put your data set in order from least to greatest, okay? So here we go. The first number is what? 66, then 67, then it's 72, 73. Does everyone see where I'm getting these numbers from? You're going to want to start that list pretty tight to the side because there is not a ton of room. All right, the next number is 77, and then there's two of those, so I'm going to list that twice. 79. There are three 80s, so 80, 80, and 80. And then there's an 84. an 85, two 86s, an 87, two 88s, 190, a 92, and a 93. All right, so again, your first step of finding the median is to put your data set in order from least to greatest. And we want to find the halfway point. So what do you guys think? First of all, we have to count how many numbers we have. How many numbers do we have there? Everyone's counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19? 20. 20. All right, very good. So, does anyone have an idea of how this would go? Where would 20 or where would halfway be? Nope, you don't count you would start, say that again, what'd you look?
Did you count the
dots?
Yeah.
Well, we transferred those dots to this list, okay? So now we're gonna work from the list. Does that make sense? So, okay, there's one way of doing this that's really old school. There's a more technical way that you guys will learn, but one way you can do it is you start with your lowest number, 66, your highest number, 93, and then you just jump in until your fingers touch. Now, if it's a small data set, this is pretty easy. But when you get into, data sets that have hundreds, potentially thousands of numbers, it's not going to work very well, that method, because your arms aren't long enough. So we have an even number data set, right? So when it's an even number, we have to find what's halfway between these two numbers. So what is halfway between 80 and 84? Kyle? 82. Very good. 82 is our median. So in this case, our median is actually not part of our data set. The median is 82. And as you can see, nobody actually got 82 fries. Okay, so we're going to kind of get moving on with this. So there is a way of doing this where you take the number of values you have and then you add 1 and then divide by 2. So in this case we have 20. So 21 divided by 2 is 10.5. So 80 right here is the 10th value, right? So we want to go halfway between the next value. Does that make sense? All right, we'll talk about it more. So I gave the example last period to some kids, like if, it's hard to visualize on this because it's just kind of a recording screen, but if I were to find the middle of, Frankie, Maya, Tim, and Willow, right? There's 4 of you, it would be somewhere between Maya and Tim, right? Where if I only said Maya, Tim, and Willow, the middle person would be Tim, right? So if you have an odd data set, it's really clear where the middle is. If you have an even data set, you're going to have to go halfway between. So technically how you do that is you add these two numbers and divide by 2. Okay? So add the 2 middle numbers and divide it by 2. All right, moving on. This question I don't really love. It says you just bought a large bag of fries. Obviously, they're all in the van right now. Do you think you have 82 French fries? Why or why not? I mean, you could kind of go either way on this. 82 would be a normal amount, right? Yeah. But nobody actually got that number. So, this is how I'm going to answer it. So, let's say nobody actually got 82 fries, but it would be a realistic amount, right? It's not like anyone's going to open their bag of fries and go, whoa, holy cow, I got 82 fries, when most of the people around you are getting 80 fries and 85, 80. It is a lot of fries, but compared to the other numbers, it's not something that's going to really draw attention. Yes?
A more realistic reason to freak out would be if you got 200 fries.
That would be worth celebrating for sure. All right, so how many bags were in the sample? We already counted. How many bags were there? 20, thank you. So 20 bags of fries. You can just write 20 bags. All right, the next question. All right, we're gonna not really explain the reasoning in writing, but it says, which of the following statements would seem to be true given the data? Half of the bags had more than 82 fries in them. Is that a true statement? That half, whoops, were more than 82? Yes, that is the definition of the median, that half of the data is above that value. So yes, that's true. Would it also be true that half of the bags then have fewer than 82 fries? Yep, that's also true. Good job. All right, and then the next question is trying to trick us. It says more than half of the bags had more than 82 fries. No, it's going to be 50% for more, 50% for less. So the next question is going to be the same thing. More than half of the bags had fewer. No. Nope. 50% had fewer. All right, and then the last question, if you got a random bag of fries, you could get as many as 93 fries. Yeah, why not? Especially if you know the person bagging the fries. Okay, so I'm just kidding. Okay, moving on. We're going to go to exercise numero cuatro, number 4. Suppose you were trying to convince... I don't like that question. We're going to move on to 5, actually. Okay, number 5 says, what percent of the bags have more fries than the median? They're trying to beat this concept into your head metaphorically. What percent have more than the median? Half. So what half, you don't say half percent, is 50%, right? So 50% is higher than the median. 50% have more than the median, which in this case was 82. And 50% have less. Question number 5B. Suppose the bag with 93 fries was miscounted and there were only 85 fries. Would the median change? Let's go back. So they want us to change our 93 to an 85, essentially. Not really, but let's say right here is a 93, and they want to turn it into another 85. Is that going to affect where that falls? No, it's not. So that's starting to allude to the benefit of the median being resistant to outliers, all right, and things of that nature. So would the median change? No, because it is, or it would still be in the top 50% of fries, right? So again, I'm not sure if I had this recorded or not. The periods are starting to run together at this point in the day. But the real benefit of the median over using the mean is that you could have some really high numbers, or maybe some really low numbers. Like maybe Ethan really ticked off the people at Five Guys, and they just gave him a bag of napkins and salt, and they said, "Here, take that." And he gets home and he's really disappointed. That would not affect our median score because it's still in the 50% lower section, right? Yes.
It's okay that I put no because it will be on the same side.
I think you can be a little more specific. You're not wrong.
Of the top
but
50%.
Yeah, add that in. Okay, any other questions? Good question. So this concept's really quite easy. The mean is the average. Now we're finding another measure of center, the median, and that just means the halfway point of your data. 50% is going to be higher than that. 50% are lower than that. So let's say if I gave a quiz and the median score was 80, that means half of the kids got above an 80 and half of the kids got below an 80. Okay? Sometimes your mean and your median will be very close. Sometimes they're vastly different. It really is going to depend if you got, like in this case, if you got a bag of fries that had 200 fries in it, Your median's going to stay the same, but your mean's going to draft, the average is going to go up because of that, a bunch. All right, so let's see. It says, suppose a bag with 93 fries really only has 80 fries. Would the median change? So let's go back. If it's 93 and it really has, how many? 80? I can't remember one number from the one page to the next. All right, so if it had 80, now that's going to go on the left side of our line, right? So is that going to change our median then? Yes, it would, right? Because then it's going to shift it over, okay? So we would say yes, it would. Yes, we're just yes. Okay, we're very good at explaining ourselves. Just back away slowly. Okay, so that's actually all we're going to do for today as far as the median. I will be showing a video that shows the importance of this kind of statistical analysis. Hopefully I can figure out how to put a link in one of the upcoming videos. What we're going to do is look at your homework quickly on page 74. So we're going to skip a bunch of this for today. Doesn't mean we're not coming back to it, but you know, there's only so many minutes. Now on your page, it's actually, I think it's 74 for you guys, right?
Yeah.
Now on this it's saying 72, but it's 74 in your actual book. And it's talking about the amount of precipitation in the western states in the U.S. And it has a table, and then they put it in a dot plot for you. And your job is to answer these questions. So I'm going to pause this while I cough. So anyway, how do the amounts vary across the states? So you can obviously see that some states are getting significantly more rain than others. Okay, so you're going to want to talk about that. Part B says find the median. So your first step is to do what with your numbers? Put them in order from least to greatest. Very good. So you're going to put these numbers in order from least to greatest. And then find the median. And then it says, what does the median tell you about the amount of precipitation? So you're going to want to talk about that. Half of those states get more than that amount, and half get less than that amount. And then it says, use the median and the range to describe the average monthly precipitation in western states in the U.S. So you want to look at how far does it span from this low amount here, right, to here. And then, again, talk about how half is less than that amount, half is less, or half is more, sorry. And then part D, do you think the mean or the median would be a better description of the typical amount of precipitation? So your last kind of job with this data set is to find the average of all of these numbers, and then you're going to have your median, you're going to have your average, and then looking at what we see on our dot plot and what you saw for numbers, which one is a better representation of that data set? Is the mean a better representation, or is the median? So you can see here we have some states that have like 65 almost inches of, is it inches? Yeah, inches of rain, and then you know, some high numbers. That's going to pull the average up, right? But is what's typical? I don't know. Compare it to the median. See which seems more typical. Okay. Thank you for watching Math with Mrs. Lehman. Time to wake up and turn off your computer. Just kidding. All right, have a great day. Enjoy the long weekend. Thank you to my third period class. Don't forget to like and subscribe. Bye.